Number 71. When the user inhales. When the user inhales. When does the diluter demand regulator operate? When the user inhales. When does the diluter demand regulator operate? When the user inhales. Think about that for a sec. So the diluter demand regulator operates. When does it operate? When the user inhales. You put on a mask and it won't do anything until you take a deep breath, until you start breathing in, right? So the diluter demand regulator starts to work to give you that breath. All right? Number 72. Aviation breathing oxygen has had all the water vapor removed. Aviation breathing oxygen has had all the water vapor removed. So the primary difference between aviation breathing oxygen and other types of commercially available compressed oxygen is that aviation breathing oxygen has had all the water vapor removed. Number 73, pressure reducer valve. Pressure reducer valve. So what is used in some oxygen systems to change high cylinder pressure to a low system pressure? You use pressure reducer valves. Pressure reducer valves are used in some oxygen systems to change high cylinder pressure to a low system pressure. Pressure reducer valves. Number 74, pressure relief valves. Pressure relief valves. In a high pressure oxygen system, if the pressure reducer fails, that prevents high pressure oxygen from entering the system's downstream, the pressure relief valves. Pressure relief valves. In a high pressure oxygen system, if the pressure reducer fails, the pressure relief valve prevents high pressure oxygen from entering the system downstream. 75. Green color and the words aviator breathing oxygen stenciled in a 1-inch white letters. So green color and the words aviators breathing oxygen stenciled in 1-inch white letters. High pressure cylinders containing oxygen for aviation can be identified by their green in color and the words aviator breathing oxygen stenciled in 1-inch white letters. Number 76, we have another figure here. So we go into figure 14. In 1 hour after oxygen in the system was charged for a leak check, the oxygen pressure gauge read 460 psi at a 63 degrees Fahrenheit. 6 hours later, the temperature had dropped down to 51. A 5 psi change is maximal allowable in a 6-hour period. What pressure gauge readings would be acceptable to remain within allowable limits? So the answer is 445 to 450 psi. But you can find that answers right there through your figures, okay? By just looking at the change in pressure, change in temperature, and just follow the line, okay? Graph it out. Once again, 445 to 450 psi. 445 to 450 psi. So if you ever see a question and you say figure 14 and you recall that it has to do with oxygen, 445 to 450 psi. All right? Number 77. With the test date, DOT number and serial number stamped on the cylinder neck, with the test date, DOT number and serial number stamped on the cylinder near the neck. So an aircraft oxygen bottle may be considered airworthy if it has been hydrostatically tested and identified. How? With the testing date, the DOT number and serial number stamped on the cylinder near the neck. Number 78. Pressure relief valves, pressure relief valves, pressure relief valves. So if a gaseous oxygen system, which of the following are vented to blowout plugs in the fuselage skin? They use pressure relief valves. Pressure relief valves. So in a gaseous oxygen system of the following, the vented blowout plugs in the fuselage skin are also known as pressure relief valves. Number 79. To make human flight possible in the hostile environment of the upper atmosphere. To make human flight possible in the hostile environment of upper atmosphere. So what is the purpose of pressurizing the aircraft cabin? So you pressurize the aircraft cabin to make human flight possible in the hostile environment of the upper atmosphere. To be able to go up in the atmosphere, you will need to be pressurized and be comfortable. Okay? So it will be possible. All right. So the purpose of pressurizing the aircraft cabin is to make human flight possible in the hostile environment of the upper atmosphere. Number 80. Okay, so only the first one is true. So oxygen used in aircraft system is at least 99.5% pure and practically water-free. Oxygen system in aircraft systems is at least 99.5% pure and practically water-free. All right, only the first one is true. 99.5% pure and practically water-free. Guys, take a quiz, and I'll see you soon.